Guys, this video is for the assessment purpose for an assignment by Skyfi Labs. This video will be designing and analyzing a 23-story tall building using ETABS with the given data over here. As we can see, we have to define the 3 column dimensions and 3 beam dimensions. We have to provide a concrete grade of M40. We have to provide longitudinal reinforcement bars of HYSD 500 and confinement bars of mile 250. We have to provide a slab of 150 mm thickness with M40 grade concrete. We'll be using the auto draw cladding option, which means that there won't be any self-attacking on the walls. In this case, we'll be providing a cladding load of 0.2 kN per meter on them. We'll consider the building parameters to be designed in Bangalore for the wind load calculation. As we can see, the lateral load sections are different throughout the story height. So let's get started. Open the ETABS software, click on File, select New Model. We'll use the Use Built-in Settings with option. We'll select the display units to metric SI, steel section database as Indian, steel design code as IS 800-2007, and concrete design code as IS 456-2000. Click on OK. As we can see, we'll require 4 grid lines in X and 4 grid lines in Y direction with 6 mm spacing between them. So we'll keep number of grid lines in X and Y direction as 4. Change the spacing to 6 meter both X and Y direction. We'll add the number of stories to 23. We'll keep the typical story height to 3 meter, also the bottom story height to 3 meter. Click on custom story data option and click on edit story data. Here we have to choose a master story, and then we have to mark the other stories similar to the master story. Let's see. From story 1 to 8, we have to add a master story of story 8. So we marked master story for story 8 and then select the other stories similar to story 8. Similarly, for this, we have to mark story 14 as the master story. For this, we have to mark story 19 as the master story. And for this, we have to mark story 23 as the master story. So we have marked the master stories and the similar stories to the master story also. And click on OK. And select the grid only option and click on OK. As you can see, the 2 windows have appeared. One window will be showing the plan view and the other will be showing the 3D view. So the first thing, we have to define the material properties. That is the M40 grade concrete, HYSD 500 bars and mile 250 rebars. So go to define, select material properties and add new material. Select the region as Indian, material type as concrete, standard as Indian and grade as M40 and click on OK. Again click on OK. Click on add material. Keep the region as Indian. Change the material type to rebar and select grade as HYSD 500 and click on OK. Again we have to add the new material for mile 250 rebar and click on OK. Click on OK to exit. Now you have to define the frame sections. Go to define, select section properties and click on frame sections. Here we have to define the 3 column sections and 3 beam sections as given. So we'll add new property, select the concrete rectangular section, give suitable name, say C 500 into 300, change the material to M40, change the dimensions, Click on Modify Show Rebar option. Make sure we have selected the PM to M3 design bracket column option. Change the longitudinal bars to HYSD 500, confinement bars to mild 250 and click on OK. So now we have to add a copy of this column. Give a suitable name, say C550 to 550 and change the depth and width. No need to go for the modify show rebar option as we have add the copy of the earlier column and click on OK. Again, we have to add a copy, give a suitable name, say C600 into 600, change the dimensions and click on OK. Similarly, we have to add new property for beams. Select concrete rectangular option, give a suitable name, say B 200 to 300, change the material type to M40, change the dimensions. Now we have to click on modify show rebar option, change the design type to M3 design only, change longitudinal bars to HYSD 500, confinement bars to mild 250. We have to change the cover as per the IS code. We provide 25 mm cover to top bars and bottom bars and click on OK. Again click on OK. Now we have to define two more beam sections. We'll add a copy of the same. Give a suitable name, say B550 into 350. Change the dimensions and click on OK. Again we have to add a copy. Give a suitable name, say B600. Change the dimensions and click on OK. So now we have defined the three beams and three column properties. We have to define a new property so that the E tabs would select the required column or the beam property. We have to select the auto select option, give a suitable name, say column auto select, change the design type to concrete, and select the three defined column and click on add and click on OK. Similarly, you have to add a property for beams also. Select the auto select list, give a name, say beam auto select, change the design type to concrete and select the three beam sections we have defined. Click on OK, click on OK again. So we have defined the three beams and three column sections. Click on OK to exit. So now we have to define the slab section. Go to define section properties, slab section. We add a new property, change the name, say slab 150 mm, change the material to M40, change the thickness to 150 and click on OK. So we have defined the slab, click on OK to exit. Now we have defined all the elements. Now we'll draw the elements which we have defined. So in the plan view, using the arrow keys, go to story 1. Make sure we have selected the similar story option. Now click on quick draw columns option. In the properties of object toolbar, select the property as column auto select and drag in the plan view. You can see we have generated the columns. Now click on Quick Draw Beams and Columns. Make sure the property selected is Beam Auto Select and drag in the plan view. You can see in 3D view we have generated the beams. Similarly, click on Quick Draw Floors Walls option to draw the slab. Change the property to slab 150 mm and drag it over to the plan view. You can see in 3D view all the elements we have drawn. Similarly, we have to do for story 9 to 14. We'll go to story 9 or story 14 or between any of them using the arrow keys. So now we are at story 10. Select the draw column option. Make sure the property selected is column auto select. Drag the column. Go to quick draw beams column option. Make sure the property selected is beam auto select and draw the beams. Now click on quick draw floor wall option for drawing slab. Make sure the property selected is slab 150 mm and draw the slab. Similarly, we have to draw for story 15 to 19 and story 20 to 23. Importantly, make sure you have selected the similar story option. So now we have drawn all the elements. Now we'll see the application of dead load, live load and the cladding load. As we can see, dead load is similar across the story height. So we'll select the all story option. In the plan view, we'll come to story 1 using the arrow keys and select the shells. Make sure your selection, go to Assign, Shell Loads, Uniform. Make sure you add a load of 2 kN per meter square. Change the load pattern name to dead. Click on Apply and click on OK. You can see dead load is applied. Now we have to add the live load, but the live load is different across the story. So we'll use the similar story option and apply the live loads. So make sure you select the similar story option. In the plan view, go to story 1 using the arrow keys. Select the shells. Go to Assign, Shell Loads, Uniform. Change the load pattern name to live. Add a load of 5 kN per meter square. Click on Apply and click on OK. Similarly, you have to add a live load for story 9 to 14, for story 15 to 19 and for story 20 to 23. Now go to any story between 9 to 14 using the arrow keys. So we are at story 10. Make sure you have selected the similar story option. Select the shells. Go to Assign, Shell Loads, Uniform. And you can see we have to add a load of 4.5 kN per meter square. Make sure the load pattern name selected is live. Click on Apply. Click on OK. Now we have to go from story 15 to from story 19. With the arrow keys, we'll go to story 15. Make sure you selected the similar story option. Select the shells. Go to assign, shell loads, uniform, and a load of 4 kN per meter square. Make sure you selected the load pattern name to live. Click on apply. Click on OK. Do same for this remaining story. So we have added live load across the stories. Now we will be adding the cladding load of 0.2 kN per meter square across the stories. Again using the similar story option. First we will go to story 1. And select the exterior beams. Make sure your selection. Go to assign, frame loads, distributed. In the uniform load, we'll add a load of 0.2 kN per meter. Click on apply and click on OK. In the plan view, you can see the cladding load is applied. Do the same for the other stories. So we have applied the cladding load across the story. In the top story, there won't be any cladding load applied because there is no walls. So we'll go to top story using arrow keys. Make sure you have selected the one story option. Select the exterior beam. Go to assign, frame loads, distributed. And select the delete existing load option. Click on apply and click on OK. Now you can see there is no cladding load on the top story. Now using arrow keys, go to the bottom story. Select the one story option. And select all the base joints. Go to assign, joints, select restraints. And select the fixed option. Click on apply and click on OK. Now we will be drawing the cladding for the building. Go to draw, select auto draw cladding, click the use blur option and click on OK. You can see the 3D view claddings are generated. Now we'll see the application of wind load. But first we have to define the wind load. So go to define, go to load patterns, type wind in the load option, select the type as wind. From the auto-lateral load, select the Indian IS 875 1987 and click on add new load. Select the newly added load and click on modify lateral load. So the wind coefficients we have to see in IS code. So for wind speed, we'll go to IS code appendix A. We have considered the building to be constructed at Bangalore. So we can see here the wind coefficient is given as 33 meter per second. So we'll change it to 33. From clause 5.3.2.1, we'll select the terrain category as 3. We'll select the structure class as C, as the height is more than 50 meters, and keep the risk coefficient and topography to 1 and click on OK. Again, click on OK to exit. Now, select elevation, select option A and click on OK. Make sure you have selected the all story option. Select the shells. So we have to first see the wind pressure coefficient. From IS code, go to table number 4. So as the height of a building is 23, so 23 times 3 is 69 meter. Width and length of the building is 80. So the height to width ratio is 3.83. So it comes between these options. So the wind pressure coefficients are plus 0.8, minus 0.25, minus 0.8 and minus 0.8. Note it down. So as we have selected the shells in the elevation A, go to assign, select the shell loads and select the wind pressure coefficient option. We'll add a wind pressure coefficient of 0.8. Make sure you have selected the windward, click on apply and click on OK. You can see the wind pressure coefficient is added. Now in the elevation, go to section B, click on OK. Make sure you have selected the all story option. Select the displayed shells. Go to assign, shell loads and wind pressure coefficient. Change the coefficient to 0.8. Make sure you selected the windward, click on apply and click on OK. Now we'll go to elevation section C. Click on apply. OK. Make sure you have selected the all story option. Select all the displayed shells. Go to assign, shell loads and wind pressure coefficient. Change the wind pressure coefficient to minus 0.25. Select the leeward or sides option. Click on apply and click on OK. Now we'll go to elevation section 1. Now as we can see, the coefficients are similar now, minus 0.8 and minus 0.8. Select all the shells using all story option. Go to elevation section 2 using the arrow keys. Select the displayed shells. Go to elevation section 3 using arrow key. Select the displayed shells and again to elevation section 4 and select all the displayed shells. As the coefficients are same, that is minus 0.8. Make sure your selections. Go to assign, shell loads, wind pressure coefficient and a coefficient of minus 0.8. Keep the leeward or side option. Click on apply and click on OK. So in the plan view, in the story 1, we can see the applied loads. First, go in the 3D view. The menu bar, click on the extrude view toggle. and click on Use Extruded View for frame objects. We have to run the analysis. Go to Analyze and click on Run Analysis. Save the building with the proper name. Click on Save. The E tab will now run the analysis. You can see over here the analysis is complete. We can see the displacement due to the load in the 3D view. Now we have to run the design. So click on Design, select the concrete frame design option and click on View Revise Preferences. Make sure you have selected a design code to IS456-2000 and click on OK. Again, go to Design, select the concrete frame design and click on Start Design and check. The software runs the design check in the building. Once the design is complete, it will show that the analyze and design sections differ for 711 concrete frames. So it will ask to reiterate the analysis and design. So it will choose from the required beams and column sections, whichever it needs. So you have to click on yes. You can see it's analyzing again. It will automatically run the design as the analyze is complete. Again, it says if you want to reiterate the analysis and design, because 11 concrete frames differ, so again click on yes. We'll run the analysis again. This is because we have used the auto select option for beams and columns. It will automatically select the beams and columns required for the section. Now it is running the design check. See, it's showing optimizing concrete design properties. Again, you have to click yes. So once the design is complete, the 3D view, you can see the longitudinal reinforcement. If you click on any of this and click on details, we can see the detail of the column section design. This is how we can see the detail for any column or any beam. So this completes the assignment of tall building design. Thank you.